And I will also start recording. Okay, so today we are going to actually do two things. We will see the Nexus components, okay, and we will Nexus 7K components specially, and then we will also see the VDC portion of it. We will do some hands-on small lab on the VDCs, how to create virtual switches, etc. So I have a 3D presentation here, which will give us a pretty good idea about the Cisco Nexus 7K. Okay, and here it is. As you can see, guys, you can see the screen, right? Is it all good?
Yep, it's good, it's good.
And the sound is good?
Yep.
Yes, sir.
Okay, excellent. So this is how a Cisco Nexus 7010 model looks like, and 7018 is going to be a little bigger. 7009 is going to be a little less. So initially it was 7010, and then Cisco actually reduced the size of this chassis, and they came with the new model of 7009, which actually gives you almost similar number of modules, which gives you 9 modules, but the chassis size is cut into half, as well as the power and the other requirements are also cut down to half. Okay. So here it is, it says lockable front door. And then you have the air filters, because it actually, you know, these amount of modules you have here and the kind of power it takes to, you know, regenerate or probably forward frame at a very high speed, you generally require a good capacity as well as good electricity, you know, amount of electricity, etc. Now that creates a huge amount of heat. So we will also see on the back that these are the air filters basically, and then you have a fan and air filters. On the sides also we have fans in some models, and on the back also we have fans, because it actually produces a huge amount of heat. And that depends on the model also, that what kind of switch it is, what is the model of switch. And so this is the cable area where you have integrated cable management. You may or may not like to use it. A lot of people use it open, but you do, from the factory, you do get this panel shipped where you can manage your cables inside it so that they don't look ugly. Most of the people in the industry I've seen, they don't really use it. Okay, now we'll see the side of it, and you can see here, this is the side panel of it. And some of the models have fans here basically. Okay, they have this called side fan, front fan, back fan, and side fans. Okay, so in the front we have these modules. We will discuss about different type of modules. We have like M module, F module, F1 module, M1 module, etc. This is where you connect the cables, different kind of cables. Sorry. So this is where you basically connect the QSFP, which is 40 gig and above, SFPs, which is 1 gig and 10 gig, generally 10 gigs, or if you have copper, you basically connect using the Ethernet cables and all that, right? So these are different kind of module depending on, so you see that these modules are all looking different, right? These modules are all looking different. If you see that, this is looking like small, 10 gig kind of interfaces. Here in this interface, you see only 3 interfaces. Generally, these are like 40 gig each. Here you see that these are even bigger. So generally, these are like 100 gig per port. So when you have more ports, when you have more capacity, you have less ports on this, right? And these kind of ports are generally used for trunking, switch to switch. So you would use a 100 gig port on switch to switch and 1 gig and 10 gig to host. Okay, so this is how the front looks like, and then we'll go to the back. So these are basically your fans. You can see fabric fan modules. Okay, and these are again your fans. So This is again system fan tray. So these are basically the vertical one, and these are horizontal fans. These fans are going inside and they are rotating inside the chassis, because that's where the modules are, on the back of module, right? A huge amount of heat will be produced. And this is basically the ventilation portion of it. No fans here, it's just the ventilation. So these are two fans, back fans, and these are also fans here. Okay, because it actually produces a huge amount of heat. We will also look at the power supplies, and these are the power supplies. Now, each of the power supply is actually a dual power supply. Okay, what does it mean? You see that two sockets in each of these. Generally, these are like 3 kilowatt, 3 kilowatt. So totally you have like 18 kilowatt here in this particular chassis at this time. So it can consume up to 18 kilowatt. One single chassis can consume up to 18 kilowatt. The real consumption may be different, okay? But I'm not sure if it will actually consume over 70% of the chassis. But we still have to provision, more power and different power supplies coming from different companies. So in US and other countries, what happens is the power supply in the data center comes from different vendors. Okay, so one vendor power supply, if it goes down, they at least have the power supply from other. Also in data center, what they do is they basically have power supply from different UPS. So let's say this 6 kilowatt comes from other one source, and this 6 kilowatt will come from another source. Okay, now I'm going to talk about the most important module here. These are the modules. These are called fabric modules, fabric bars. Okay, and also known as crossbars. The crossbar modules are basically called the backplane capacity. You see that here, each fabric module delivers 46 Gbps per slot. Okay, so these are two which is actually inserted, and you have a space for 3 more. So total 5 slots possible, right? So total of 5 spots are there. So the purpose of these crossbars basically is to connect. We'll go back to front, and you see that here 2 supervisor modules are here. These are supervisor modules. Yesterday I told you these are the brains of the switch, of the Nexus switch, right? Your operating system, all your images, all your software, all your configuration stays on these, and they don't do any forwarding. They're control plane. These guys, everybody else, all other kind of modules are basically the data plane, and they do all the forwarding, but they take instruction from whom? The supervisor one, right? So what happens is, now these people, if you see that these modules, if you see that they are not connected to each other in somehow, they're connected using a bus, right? So they're connected in the background using a bus system. Now what happens with the bus is that these people need to have some communication to each other, which means if this module want to communicate to this module, or if the supervisor also want to communicate to these modules, you need to have somebody connecting them. Right? We need to have somebody connecting them. So what is that? What is that somebody going to be? That somebody is the crossbar. These crossbars are basically responsible for connecting the IO modules. These are your F1 or M1 modules, the IO modules to each other. So the throughput of the chassis, when we talk about the throughput of the chassis, right? Basically that depends on these people. What are the number of modules you have? So if I click on this module, how much is the bandwidth here? 46 Gbps, right? So these are 2 modules. So how much is the total throughput of this particular switch?
Hi, Vikas. I'm sorry for interrupting. Can you hear me?
Yes, I can. Yeah.
I'm sorry. As soon as the class started, the router went off. I mean, my internet went off. I couldn't listen to anything. I just rebooted and connected back again. So probably I missed from the starting whatever you taught till now.
No problem. So I have the recording available, and at the end of the class, I'll send you this recording link.
Okay. Can you just give me a brief so that I can start understanding from now?
So I'm just giving you an overview of basically the 7 Ks. I explained the front view basically, where you have the modules and the supervisor module, and these modules, how they communicate to each other. what is called throughput. So throughput is actually the communication between these people, right? The throughput is basically the amount of traffic that the switch can handle. And that basically means the amount of traffic, which is throughput, which means input and output both, right? How much can enter through it and what is the amount of traffic that can come out of it. So that throughput is basically decided based on this fabric module called crossbars. So here in this example, there are two modules available, right? These are two modules available, but we have 5 slots available, which is 3 more slots which are empty. Okay, because of the cost reason or something else, this guy may not have put those, but generally it's a great idea to put all 5 modules if you are running on a full capacity in your data center. So now each module, if you look at it, is around 46 Gbps. So 2 modules are how much? 92 Gbps. So we can say that the throughput of this Nexus chassis is directly proportional to the number of fab modules you have. Guys, cool? Any doubt on this? So throughput of the whole chassis, which is what is the bandwidth that any 2 modules can communicate on, right, is decided by the crossbar. So this is the most important element into Cisco Nexus environment. I will also go to Cisco Nexus crossbar or fabric modules, we call it. Okay, so here it is. This is how it looks like. Cisco Nexus 7010 slot fabric module. And if you see that there is no input output port here, right? So it's not an ordinary module. You can't connect anything to it. What's the purpose of this module? To connect different IO modules to each other. So this is the backplane. It will not be wrong to call it the backplane guy. This is the one which is connecting the backplane here. You see that the definition here, Cisco Nexus 7K fabric modules for the Cisco Nexus 7000 chassis are separate fabric modules that provide parallel fabric channels to each IO and supervisor module. Up to 5 simultaneous active fabric modules work together, delivering up to 230 Gbps per slot, right? So this is what is basically your fabric modules. Now these are not F modules, those are different. And we'll discuss about that. These are crossbar. So easy name to remember them is crossbars. Right? So the throughput of the switch basically depends on these particular modules. So if somebody asks you to calculate an exam or anywhere else, what is the throughput of my chassis? All you need is to know is what kind of fabric modules do we have? So let's go back here. In this now, different kind of modules are there. So Cisco fabric module, IO sheet, something like that. Or specific. So here it is fabric 2. You see that? So this is not the same, it's fabric 2, and this is for 7700. Okay. For 7000 also we should have, here it is for 7000 also is there. And if I go back to this, I think this will give us a better idea of maybe the same link. So now we have fabric 1, fabric 2, fabric 3 available in different models. And the old modules were like 46 Gbps per port or per module. Now you can have up to 110 Gbps per module. So into 5 is 550 Gbps maximum throughput on the old chassis. Okay, so here it is, should be somewhere here. So these are supervisor modules, so we'll come back to that. And these are supervisors. So Cisco basically has version for them, like version 1, version 2, version 3. Same thing is they have basically for every single thing, they have, you know, the similar kind of numbering basically. So Fab 1, Fab 2, Fab 3, or here in the front, if I talk about, Cisco has M modules and F modules, which is again M1, M2, and M3, which is nothing but the newer version. So M1 was the old module, no more into production anymore. M2 was an old module, no more into production now. And M3 is what is being used. Recently, Cisco also launched M4 modules. Okay, so let's go back to Notepad to see what kind of modules we have. So these are crossbars. What's the purpose of it? These are basically connecting IO modules through backplane. Then further we have two important modules here, or rather three modules. Next is supervisor module, right? So now supervisor is actually the brain of it, of the chassis. And this is actually where you keep your operating system, the NXOS. So it consists of, it has the SD card, and it basically has the OS and all files, your files, configuration files, and system files, and everything else basically. Okay, now supervisor modules as, okay, let's go back to crossbar ones. We have Fab 1, we have Fab 2, and Fab 3 now. In soup module, we call it, the supervisor module, we have models number soup 1, soup 2, soup 2E. Okay, what are these? These are superior models. So this is an old one, okay, a better one, and the newer one. What's here is the same story. The old one, they had a better one, and then the latest. Cool. So now coming back to supervisor, we will actually go here. Cisco supervisor module, Nexus. Okay, so this is how a supervisor module looks like. It has a console port, so you can directly put a console cable and start configuring it. So this is the only place where you have the console. Okay, they have no IO port. This is a management port. You can do telnet or SSH or HTTPS to the switch, and you can manage it. And this is auxiliary port basically. So these are different kind of ports. This is an old module basically. Okay, so this is same thing. Now this is more, they are basically talking about what are the features you have, the OS and other files that you have inside it, which is more like OS features. So this is how, you know, I'm not sure if you are able to clearly see it. There is an auxiliary port, there is a console port, and there is a management port. Management port, you do telnet SSH, give it an IP address like you give to your wireless router, the inside IP and the outside IP, etc., and you start telnetting or SSHing to it. You can insert an image using USB as well. If you want to copy paste something, you can use USB. Ports are there on the supervisor. So if you have an image in your USB, you can put it here and then copy back to the supervisor module, which has an SD card inside it. So you see that here, compact flash card. Inside it, you have SD card here, and on that you can basically rewrite or you can save the configuration. These are the various features of your supervisor module. What kind of processor? Generally Intel Xeon is the motherboard and the CPU, and 4 GB, 8 GB, 16 GB, and 24 GB kind of models are basically available, depending on what soup module are we referring to. These are the SD card or the compact flash card. You can actually have a bigger one also these days. Okay, so the supervisor modules, when we go into more depth of doing things in the VDC and all that, then I'm going to cover actually what is more different about these people. But for the timing, this is good enough to understand that these are these modules. The next one we have is M1 module, which is basically M modules rather. These are actually layer 3 and layer 2 modules. What does that mean? Basically, it supports all routing features, protocols, and anything L3. So if you are going to use any routing protocol, any kind of VPN, any kind of MPLS, any kind of L3 configuration, you need to have or have to have minimum one M module in your chassis. You need to have minimum one M module in your chassis. Otherwise, your layer 3 functionality will not work. It will become a pure L2 switch, which means if you try to create any layer 3 interface, it will not accept it. So if you're doing SPIs or you're doing any kind of L3 switching, it will not work. You need to have minimum one M modules into your system. Again, you have M module, which is older, M1, M2, M3, and I told you M4. Of course, each of these modules basically has a better capacity as compared to the previous one. So this is the latest one. These are like generation of cars. M1 generation, M2 generation is like version numbers. Okay, so what's the difference? The port speed will be different, the throughput will be different, latency will be different, and Cisco keeps on improving everything. So per port latency or throughput of the interfaces and all that will be all different. The better, the latest one is going to be better. Okay, the fourth type of module that you have in the chassis is F module. Okay, in which you basically have pure L2 functions and spatial features like FCOE and fabric path. Basically these two, no third function. So if your company wants to use FCOE or fabric path, you have to have an F module. It will not work on M module because these two functions are only supported on F modules. And both the functions are actually very high in demand in the market. These are like amazing features. If you ask me what is the best thing that Cisco Nexus chassis has given, is actually the fabric path, replacing spanning tree at the core. Killing the bottleneck, finishing the bottleneck from the data center network, you know. Now again, F modules have F1, F2, F3 modules, which is again, this is the latest one with the better capacity. So these are four type of modules which are basically there. Okay, the crossbar is always on the back, but in some models, latest model, they do have in the front as well, like 7009 and all that. Okay, so this is, you can have up to 5 modules on the back. These are generally on the back, and these are all 3 in the front. So all these 3 are going to be in the front. Guys, any question on this? Any kind of question or doubt on this?
Vikas, what I'm trying to understand is, so in a Cisco chassis, we're going to be placing all these modules according to our requirement, correct?
That's correct, yes.
And so, and when we talked about 7K series, that is a series for specific OS, Nexus OS, or that was specific switch series? I kind of got confused a bit.
Yeah, so Cisco Nexus 7K is purely a Nexus data center product switch. And yeah, these modules basically you know, generally choose it based on what is the kind of capacity and which features you need and what licenses do you need. So the license portion is the next one that I'm going to cover.
So this is different than the 7K series? I mean, that's a separate switch altogether?
It's a 7K. It's a 7K series product.
Okay.
I'm talking about 7K. These are all 7K features.
So 7K is a switch or is a chassis? I mean, chassis is where you're going to put all these modules to make.
7K is a series in that you have multiple models, right? So this is where in one of the chassis you put that. Chassis is blank.
Correct.
When Cisco ships you the chassis, they don't have any modules. So you have to buy based on what is your requirement. If you want better throughput and you have money to buy this one. If you have better money, more money, this is double of the price or triple of the price of these two.
So after combining all this is going to make a 7K series switch.
That is correct. Yes.
Okay. Okay.
In fact, when the Cisco, when you want to place the order for a Cisco Nexus chassis, you just get the chassis, not even the fans. You have to tell what kind of fans you need, what you need AC power supply or DC power supply. Based on that, they will actually ship you the power supplies. So chassis is completely blank, empty chassis.
Okay. Okay. And depending upon what chassis we are buying, it's going to support different modules, correct?
That is correct. So most of these are actually supported on all the models except on 7004. The fab are all built in. So this is just on 7004. These are not required, but rest all other chassis you will require all these.
Okay. So I'm trying to understand, when we combine these all modules in a switch, it's going to make a 7000 series switch. Is that correct to say, or?
No. So 7000 is a chassis number.
Oh, it's a chassis number. Okay.
Yeah, it's the chassis number. It is just going to complete your chassis, the switch, but the chassis number belongs to, or the switch thing belongs to the chassis. So we say 7009 chassis or 7018 chassis, which means a blank chassis with 18 modules to be inserted inside it.
Oh, got it. Got it. Okay. Perfect. Okay.
Okay. The second thing is you can choose to put as many number of modules as it can support. So if you have, let's say 7018 chassis, which can have 18 modules, you can choose to put only 2 or 3 modules. That's absolutely fine.
Okay. And by modules, it's going to be depending upon as many slots we have, correct? When we say 16 slots, each slot is going to be for one module, correct?
That's correct. So if you say this 7010, you see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7010.
Correct.
So this is 7010 is because it has 10 modules capacity.
Okay. Yes.
Right. Perfect. 7018 is 18 module capacity. In this, always two slots are always for the supervisor modules.
Understood. For the brain. Correct. Okay.
Right. You can have only one, but in that case, the failover will not be supported. If you would want to just have one supervisor, that's acceptable, but Understood. You will not have the failover.
Correct. And each module that we're going to place will be having different ports depending upon the module.
That's correct. Yes. Yes.
Because we're going to be connecting the devices to these modules, correct?
Yeah. So you will be basically connecting your servers to these ports.
Okay. Okay. So each module that we're going to be placing on the chassis is going to be having their specific ports, and we're going to be, and so for example, if we're going to be having an M module for layer 3 and we're going to be having an F module for layer 2 function, and we both have 2 modules placed here, and we want the switching and the routing both to happen, they're going to communicate. How will they communicate between each other? They're going to communicate using what do we say? Which was that? Fabric modules?
That's right. Absolutely. So they will have to actually use the backplane modules. These modules will support communication between 2 different modules.
Perfect. Okay. So if I'm using a device is connected to M module and which for layer 3, and a device is connected to L2, F module, which is a layer 2 device or something, and we want a communication to happen between them. If we're going to be configuring that using the backplane F fabric modules, correct?
That's correct. Yes, that's correct. Yeah.
Okay.
So any of the module, even the supervisor want to talk to M1 or F1, they really need to go back to the crossbar, and that will facilitate communication between any 2 modules out there on the front.
Got it. Got it. Perfect. Perfect. Thanks. Thanks.
Okay. Excellent. So now, coming back to these modules, we'll go into a little bit more complexity here. So let's say you have, so we basically further go to VDCs and we create virtual switches, and you require pure L2 functionality in one switch. So what kind of module, if you just have L2 switching requirement, you will basically use F modules. Although, if you do not require these two expensive modules, so I'll tell you which is the most expensive module out of these. This is the most expensive module. This is almost like 4 times the cost of M1. Now, if you see the M1, M1 is where you support, it supports all L2, like spanning tree, rapid spanning tree, multiple spanning tree, and you name it, it supports every single possible L2 functionality. And every single L3 possibility, function out there, which is BGP, MPLS, VXLAN, other functions and other things and all that, right? It does support all that. Now, you must be asking, why is this module more expensive then? Okay, so because of these new advanced features, which are only supported on this module is actually very, very expensive. These are all, see, BGP is open standard, OSPF is open standard, ISIS is open standard, spanning tree is open standard. So Cisco it's not costing them to actually have all those features here. But FCOE is, the implementation of Cisco is quite proprietary. Fabric Path is Cisco has spent a lot of money to trying to replace spanning tree with an amazing feature. So they actually want to, this is something very killer feature that Cisco has, and they want to actually make a lot of money with it. So that's how this module is very expensive. It does not support any layer 3 functionality at the same time. Okay, so if you want to run anything, you have to have minimum 1 module for running L3 and L3 capabilities, which means any routing protocol, any L3, even an IP address you want to give will not be possible on the switch if you do not have this module. Let's say if your switch has completely only these modules and supervisor module, what will you do? Won't help.
Layer 2 switch.
Right, it's pure L2. If we want any one single functionality of L3, we have to have M modules. Okay, so if you want L2 functionalities, you can go with M modules. If you don't have budget for that, okay, I would recommend you to go for M modules also, because M modules do support all L2. F modules, if you have these 2 amazing functionalities required, you can basically go with it. Now, just having these modules does not make sure that you are able to have, or basically you have these functionalities running. Okay, Cisco will charge you for these modules. At the same time, you need to have licenses for these. Okay, or anything that you require. So Cisco gives you a very basic Nexus license, and it gives you 120 days of evaluation licenses. Rest it has a, so I'll just say Cisco Nexus. So these are basically those are ACI features. So we'll not look at that. We'll look at. Right, so here it is 7Ks or 9Ks with the Nexus kind of features you need. You have enterprise service package, which will actually support OSPF, BGP, PIM, multicasting, VXLAN, BGP, and all that. You have fabric licenses for MPLS. This is basically a transport license in 7Ks. If you want any MPLS related stuff, if you want, this is I think 9K, so this is more 9K specific thing. If you have FCOE, you need to pay FCOE. And most of the time, I'll tell you, right, the license fee of the Cisco is 2 times more than the chassis itself. So if the chassis was costing you, let's say 1 crore rupees, the license will cost you 2 crore rupees. That's how, how expensive these products are basically. So Cisco makes a lot of money on the licensing part of it. So you see the VDC here. For you to have VDCs, you need to have LAN Advanced Services Package. Okay, if you want additional VDCs in some platforms, you basically need to have advanced VDC licenses. And you have, for OTV kind of features, you require transport service package. So whatever feature you need to have a license. If the license is not enabled, that feature will not work. Okay, so just having the chassis is not enough. But for training companies like us, we can actually work with 128 days license, okay? And that actually goes for 120 days. Okay, it gives you full feature availability for 120 days. Then you have to reset it. Okay, guys, any question on the licensing part of it?
So licenses are based on the features, not on the basis of modules. So the basis of whatever feature you're looking for, correct?
Absolutely right. Absolutely.
So per license, I mean, for any one feature, like switching complete feature, one license, or per feature, like STP one license and
No,
other.
no, it's basically it's basically based on the feature itself, not based on the per this. So basically, if you look at the licensing here, okay, let me give the username password here so that I can show you one practical and the licensing on the real device. Okay, we'll go back to it. So you see that here on the top will go the enterprise, LAN enterprise license. If you purchase, it gives you actually these protocols. So that is one type of license. It will only give you these routing protocols, nothing else. If you want SAN, you need to buy SAN license. If you want to buy, and if you want to do VDCs, you need to buy another license. If you want to have OTV kind of advanced features, which are amazing features, you need to pay for transport service package, because these are proprietary Cisco features. If you have advanced modules, I forgot to tell you about the advanced modules. So these are basically M1 and F1 modules with XL, extra large. Okay. So you have M1 modules and F1 modules. Cisco actually wanted to come with new creative ideas of making money. So they came with M1 module, and then they came with M1 extra large. Like you have the t-shirt size and other place size. So you M2 XL and all that. So what is this extra large is that this module used to support certain amount of IPv4 route, certain amount of features, certain amount of routing tables and all that. The extra large actually doubles it or increases it by a couple of times depending on which feature you have. So these extra large modules, same module with extra large capacity of or more memory. Cool. So Cisco did try that. I don't think so. They were very successful because customer got furious. You're sending one module and then you are basically getting into the t-shirt kind of business where, I sell you this and then I'll sell you extra large of the same module. And then they actually stop these practices. So you recently see that they don't do this anymore. Okay, so you need to purchase modules which are extra large. Then you need to buy the license, which is extra large, which is very expensive deal for the customer. Customer did not take it very nicely. If you want fabric path, it is the feature, enhanced layer 2 package. So you need to have, if you want these features, you need to buy this license. These are like each feature is like 20 lakhs license fee for one chassis.
So each license is for a limited period, or is it like a forever?
No, it's for the lifetime. Okay, I'm trying to log in into it. So the licenses are lifetime licenses, basically. You don't have to pay again if you purchase any license at once, one time. You don't really have to purchase anything again. Okay, something went wrong. Okay, it looks like somebody has given the wrong password to it. Guys, give me a second. I need to get the password from somebody. Just 1 second, please. Okay, guys, I got it. Okay, so this is a Nexus chassis. It's a 7000. I'm just going to show version first so that you can see. And we can see that the version here is 7.2. That is the image, and we will also see the chassis, which should be the chassis is 7009. It says 9 slot. Right, it's got Intel Xeon processor on the supervisor module, and it's got 12 GB of RAM. The host name given to it is Nexus 7K1 and 7K1. Okay, so it tells us what model it is. So 7010 was a pretty old one. Cisco came up with the 7009. Okay, and it's a 9 slot. We'll also see what are the modules. Show module. And we can see that it has one supervisor module, one M1 module, and one M132XP, which is a 10 gig interface. It has also another M1 interface, which is basically 1 gig to, 10 Mbps to 1000 Mbps, 1 Gbps kind of module. So this is an old module, and it's an Excel module, interestingly. Right? So this one is an expensive one, an Excel module. And the soup module I have is Supervisor 2, soup module 2. These are the image versions, which is NXOS operating system. I'm going to cover what is Kickstart and what is system image and all that. And these are the crossbars. These are the fab modules, fabric modules, not F modules. Remember that there is a difference between crossbar and F modules. These are fabric modules, which are basically the crossbars. So here, the crossbars, fab modules, fabric modules. F module is different. Okay, so these are the crossbars. Okay, now we are going to see show. We did show module, we did show version, and we are going to see show interface brief. Show IP interface brief. And I can see that I don't have any. I think we are in the admin VDC, so I'll do show VDC. Looks like I'm in admin VDC, and I'll explain what is that basically. But for the time being, the admin VDC cannot have an interface. You are into virtual device context, which basically is used only for management, and we cannot assign any interface. So you see that there are other VDCs out there, okay? There are a couple of other VDCs out there which has the modules, but not us. We will also do show VDC membership, and you can see that the modules are basically assigned to other VDCs. These are the modules. These are assigned to other VDCs and not to the admin one. Okay.
These are the IO modules. No.
So let me go back to the module command again.
And I'm also saying when we saw the modules, there is only M module and the supervisor module and the fabric module. We don't have any layer 2 modules. So
no, this is layer 2, layer 3. So we don't have F module in this chassis. Okay. You know, we don't have F module in this particular chassis because we have it in other chassis.
So I mean, F module is basically for layer 2 functions, correct? Okay, so this chassis doesn't have any layer 2 module. So this is not going to act as a switch.
No, so let me come back to the modules again. This is M module, and M module has L2 and L3 all features available.
Oh, it is L2 as well. Okay.
Except these two.
Got it.
This guy has L2 all functions and these two specific functions, which are very expensive.
Understood.
Okay, so we basically can do all kind of spanning tree, port channels, any kind of spanning tree, multiple spanning tree, rapid spanning tree, HSRP, VRRP, everything with this particular module. No limitations on this, except that these two very advanced features will not work on this module.
Because actually this fix, which model it support, fix?
Faxes are actually supported by both.
Both, right? Okay.
Yeah.
Just forget it.
Okay, so let's go back to this one. We'll do a show run to see what's there in the configuration. And you see a couple of configurations here, and you see that one of the VDC basically has the number of IPv4 route, unicast routes, unicast IPv6 routes, multicast routes of IPv4, multicast routes of IPv6, a couple of other features. How many VRFs can you create? How many port channels can you create? How many VLANs can you create, etc. Right, so I'm going to cover all that through when I cover the VDC, but for the timing, this is just to do a show run kind of thing. Okay, so what we are going to do is we'll do a write erase. You want to write erase? Yes, we want to write erase. We'll delete everything from this and we will do it from scratch. So do a write erase like you do on the iOS and do a reload like you do on iOS, and that's good enough. Okay, now this process takes around 5 minutes. So I'll actually cover the concept of the booting process in which you have the images. So we have 3 images, which is BIOS image. Okay, and before BIOS, we have something called a golden BIOS, which is a mini BIOS basically. Then you have the BIOS image. Then you have a kickstart image. And we have a system image basically. So these are 4 images. This is like mini BIOS. If your BIOS gets corrupt, this guy, there's no configuration, there's no file in this. What do? You still have a way to basically repair this guy here. So this is a mini hidden golden BIOS, which you, once you put a golden BIOS in Google, you will actually find it how to enter inside it and how to recover from a BIOS damage or this. So then you have a BIOS image, which is a basic operating system to boot up the image. This is your Linux kernel. So this is your base Linux kernel. Base operating system. This is where all features reside. So all your features, all those licensed features are going to be in the system image. So once you boot up to here, you don't really have much. Okay. So golden BIOS is a pointer toward the BIOS that boot from this BIOS. Okay. The BIOS image has the kickstart image, which tells that in the BIOS, it is the pointer is that first we should boot this particular image. If you have multiple kickstarts, you may have possibility in your system that you have multiple kickstart. It will point toward the one that you have opted to boot from. So let's say you have version 7.1 to boot from, and you have a couple of more images on that. So you can choose to boot from this. And then once the kickstart is there, the kickstart has further a pointer telling that this system image should be booted. Now, the important point here is you should have these exactly same. If you're downloading it from Cisco and you have something like this, make sure you have something like this. If you do it like this, it won't work. If you do it like this, it won't work. If you do it like this, it will not work. You need to have exactly same image. So when you are downloading from Cisco site, if you are upgrading your Nexus JC to the new image, make sure your kickstart and system image are exactly the same. Okay, so we'll see the booting process is going on. We'll see what's going on here. So you see the BIOS, the basic BIOS. If your BIOS is all good, you don't need to get into golden BIOS. Okay. So your BIOS is basically telling, where is the pointer? What is the next image? The next image is basically going to be kickstart image. You see that kickstart 7.2.2.d1.2.bin. That's the image. Okay. Once this is inflated, your basic operating system Linux kernel to secure the image and everything else is loaded. Further, you will go to the system image, which is basically this. And you see that model here again, 7.2.2.d12bin, but this time it's not kickstart. Nowhere it is a kickstart, it's a system image. On the top, what it was a kickstart image. In the image itself, it was a kickstart given. Guys, any doubt, any confusion on this?
So the operating system that we have is going to be Nexus, as we talk about, correct? It's
Correct.
Different. So which of this is going to point to that?
These are all Nexus images. These are, so this is both Nexus images.
Oh,
These
okay.
So it doesn't use one image, it uses 2 image combo.
Okay, got it.
This has the basic Linux kernel to have a secure, loading up. And then on the top of it, you load the system image, which has all the features, the BGPs, OSPF, MPLS, OTV, VXLAN, all those features are basically in this image.
Understood.
And this image is always almost like 20 times heavier than this one. So if you check the size of this, this is going to be very small image as compared to this one. This image takes a lot of time to boot up. Right, so if you see that here, it's taking a lot of time basically to boot up from that. It's going to pick up all, you know, one by one, it will load the features. This was very quick. It was like damn fast. It's picking it up from the flash cards, the SD cards or the flash cards that you have on the supervisor module. So we can also see that is basically, if you are familiar with Linux format, you can see that it is basically the compact flash card it is booting it from. Now, this is basically going to do a post, which is basically power on self-test, right? So once these images are loaded, it is going to do a post, which means a complete diagnosis of each module, component, etc., and images if you have any. Okay, so basically let's put these two, modules and components, like power supply, like your all modules, even to the extent of that these modules, their knobs, are they closed completely? If the knob is open for any module, the module is a little loose, it will actually give you the message. All the fans, if the fans are not working, any one fan is not working, it will actually find out from the post. Nexus chassis has amazing sensors, and through these sensors, it can easily find out if there is anything wrong going on somewhere, it can actually find it out. Okay, so I just, you see that here, what's going on in the background says VDC 1 has come online, which is basically the default VDC. Power supplies are okay. It has only one power supply number 2. It doesn't have more power supplies. It has 3 X bars, crossbars. Okay, and it's basically loading up the fan modules and module 4 and module 3, which is, what is that? M modules. This is M modules. So it's actually have tested and checked every single thing out there. So it was asked me about auto provisioning. Yes, we don't want to do any auto provisioning because we want to configure it ourselves. The default username is admin, and the password is what we have to set up. Do you want to enable admin VDC at this time? I will say yes. Okay. And here I am. This is a brand new switch with no configuration whatsoever. It has only one virtual switch at this time, which is called the admin VDC by default. And from here, I can create as many virtual switches as I want to create. Okay. Now coming back to VDC, yesterday we had a basic idea about it, that you can have one switch and you can basically create multiple virtual switches out of it. So right now this is one single switch, and this is called admin VDC, virtual device context. This whole switch, whatever module it has, these are the modules I have right now, 2 only. I'm not using full capacity because we are not in production environment. and I have a supervisor module. So I have a M module and I have another M module, which is 2 M modules, different modules. I have supervisor module. I'm connected right now to supervisor. I'm on SUP 2 right now. So how is that I'm accessing this device? I am actually connected on the console port of the Nexus switch using a terminal server. So here is my terminal server, and using this particular Ethernet port of terminal server is connecting to internet, right? I am coming from the outside world here, right? So from here, I'm telnetting to this guy, and using this particular telnet server, I'm actually connected to the console of it. That's the reason I'm able to do the console configuration, because as of now, there is no telnet IP setup on the management port of this guy. You know, you can see it here. There's a management port, but nothing is configured on that. I have not configured any telnet IP address because I'm connected on the console right now. I don't need to do that. But if I want to manage it using direct telnet to the switch, right, I definitely need to have an IP address. Console is you connect first time, right? You connect it to the console for the first time. You do the configuration, and rest of your life, you probably will be telnetting to those devices. Console access is a very dangerous thing, right? You plug in directly on the console to the device, very dangerous thing. You have full access to everything. Now here I can do show users, okay, or show users, and I can see only one user right now, and I'm using that. I did set up some password for this particular admin user. I can also see show user count, and I can see right now this is the only one. I can do show roles, and you can see that there are a couple of roles. If you want to assign any particular role, which I'm going to cover tomorrow, about different roles are there. Okay, now let's go back to the basic configuration, which we were here. How do I now go back? And I need to create a couple of virtual switches and assign them as departments. So let's say customer comes in, maybe Pepsi, and Pepsi says, give me a switch. I want to have all my servers in your data center. I'm going to house those servers inside your data center. So why don't you give me a virtual switch with the 10 gig port each, maybe 8 ports. Okay, so he says, give me 8 10 gig ports. 8 ports, each is 10 gig, 10 GB each. Okay, and this is going to be Pepsi. Then, you know, somebody else comes in, Coke, and he says, you know what, give me a 16 port switch, 10 gig each. So I'll go with 16 ports, 10 GB each. Right? So you can achieve this using the single chassis. You can have these modules pick up 8 ports from either of these, you know, depending on what ports are these. So let's say 8 port, you pick it up from here and assign it to Pepsi, get 16 more ports and assign it to this guy. You have 8 more ports left in 32. If it is 32 port module, you can have more VDCs. Okay. So SUP 1 and SUP 2 can give you 1 admin plus 4 data VDCs. Admin is just administration can be done. This is a management guy, cannot do anything on his own, cannot run any routing feature, L2 feature, nothing really this guy can do except admin function, which is he can administer these 4 VDCs out there. Okay, these platforms have a limitation of these. If you buy the license and you buy this module, you can have 1 plus 8. 1 admin and 8 data VDCs, but only this platform as of now supports these 8 virtual switches. Cool, guys, any question and doubt on this? generally people have.
I'm trying to understand. So you're saying and when we're using supervisor 1 or supervisor 2 modules, we can create only four data VDCs. I mean,
That
these
is
data
correct.
VDCs are different than the VDCs that you created here with
No, it's the
Pepsi
same
and Coke.
thing.
These
It's
are
the same thing. These are the VDCs that we call them data VDC actually, because
okay.
here is admin.
Okay, so we can create only max 4 VDCs.
Right,
Okay.
which basically let's call them virtual switches. So 4 virtual switches is what you can create.
Okay, so if we have more modules, if we have more amount of ports left there, and 4 VDCs are already created with less number of ports, then the rest of the ports will be wasted.
That's correct, yes. So either you can pick up more ports from here and assign to Pepsi and Coke. There's no limitation of how much can you basically assign. You can pick up all your modules and can assign only to one VDC. It doesn't matter. So let's say you have a 7018 where you have around 500 ports. You can assign all 500 ports to Pepsi. That's absolutely fine. Or you can pick up 250 ports here and 250 ports here. That is also fine. Or you don't want to have that. You want to have 100. So basically you can have 100 ports here and 100 ports here. Now in that case, you have 300 ports balance here.
Okay, so let's suppose we have 4 VDCs and each VDC has 100 ports. That means 400 ports have been consumed and we are left with 500 ports more. Now, even if we have those 100 ports, they cannot be used. They can be used with those VDCs if required, but we cannot have more VDCs. If that's the limit, then 100 ports will be wasted.
That is correct. That's correct. Yes.
Okay.
So we need to buy this module and the license, extended VDC license, to have 8 virtual switches VDCs there.
Okay.
Right. So 2 things. One, we need to have license. The second is this module, which is very expensive actually. Okay. So what I'm going to do is I'll create 2 of these VDCs and I'll assign a couple of ports to them. So I'll create a VDC. How do you create it? First, let's give it a host name. So I'll just say host name and Nexus 7K1, which is, you see the name, the admin VDC name got changed. So the main switch name got changed to Nexus 7K1. Now I'm going to go and change a VDC Pepsi. I'm creating one and then I'll go back to another one and I'll say Coke. And he says, the license is not there. So what I do, license grace period, which gives me 120 days of licenses to do all that. And then I'll go and create another VDC. I may have a requirement right now to create another VDC, which is basically Nike. I have another customer coming. He says, I'm putting my servers there and maybe, Puma. I'll try to create another one, Adidas. And you see that we have reached to the maximum limit of VDCs here. You can have 1 admin, which is this guy, and 4 more. We try the 5th one with SOUP 2 module. It won't work because we have reached to the maximum limit of number of allowed VDCs.
Sir, I'm in a slight confusion here. Are we in supervisor module or are we in admin VDC? I mean, where are we configuring all this?
We are actually configuring it in the supervisor module. Inside that, I am given a space called admin VDC. So whatever configuration happens in the supervisor module. I'm actually connected to the console of the supervisor module.
Okay, and I got that. But we are creating VDCs inside admin VDC.
Admin VDC can create these things. So that will be correct to say that, yes, you are in the admin VDC and you are actually creating all other VDCs because only he has the authority. Remember that these VDCs cannot create anything.
Okay.
They are their self slaves. He is the master because he's the admin, he's the root user.
Yeah, I got it now.
These are like, the users created by this guy who can only do their task.
Okay. Thank you.
now I have four switches here, if you see that. So I'll do show VDC to C, and I have 4 VDCs here. So this is my admin. You see that here? And then I have Pepsi, Coke, Nike, Puma. Right? 4 clients I have in the company. Now, if I do show VDC membership, you see that none of the interfaces, they don't have any interface. These are all blank. These are the interfaces available on the switch, which is VDC 0, which is default VDC where no port is assigned. Okay, this is where you have all ports which are not assigned to anybody, they reside here. This is like blank space. Okay, you cannot enter into it, you can't delete it, you can't create it, you can't do anything with it. All ports reside here. As soon as you assign a port to somebody, the port will actually come out from this space and will be assigned to that. So we'll do that now. We'll go back to Pepsi. And I'll say allocate interface, right? And which module I want to assign. I want to pick these one. 1 to 7. You see that? So this is very interesting concept. It says entire port group is not present in the command. Missing ports will be included automatically. What you excluded is this. So what happens in the older module? This is a problem with the old switches, right? The old modules. We used to have modules where the ports were actually part of a port group, which means, let's say you have these 8 ports, port number 1 to 8, port number 1 to 8. And they will be part of one single port group, which basically means they are actually sharing one single ASIC. Was that your dedicated CPU, your dedicated memory for this number of modules? One port group has these ports. Maybe another port group has another 8 ports, another 8 ports. Now this is an old concept. At the start of the Nexus series, Cisco used to have it. They don't have it anymore in most of the new modules, which means you can actually have any port being assigned to any VDC, which means you can even pick one port and it will not create any problems, right? But the problem here is if you pick 1 to 7, it will assign 8th as well. Right? Because they belong to same port group. So this is called PG, port group. Okay. So now let's go back to this VDC and it says, you know what, this is the message. He says, I'm going to assign this as well because he belongs to this particular port, belongs to the same VDC here. Okay. Now I'll go back and I'll say show VDC membership. You see that I assigned 1 to 7, but the 8th came over. Right? Why did this happen? Because of the port groups. These ports were part of the single port group, these 8 ports, 1 to 8. I assigned 1 to 7. Right? That's not possible because this port also belongs to the same processor, the same port group, which means the same ASIC. Right? The same electronics piece which controls these 7, 8 ports. So if any of the port you leave it here, it will not accept that. You have to basically pick up all 8 in the port group of 8 ports. It's a bundle. You can't take one. You have to take the bundle. These days, new modules do not have that limitation because each port has its own ASIC. Guys, any question, any confusion on this? Okay, so we have assigned these interfaces here. And you can see that it's a one single switch. Now, how do we get into it basically? So it'll say switch to, or I'll get back here, switch to VDC PEP-C. This is how you enter into the virtual switch for the first time. And it's asking me, you are entering in the virtual switch for the first time. Please set up your password. And I'm here and I say show interface or show IP interface brief or show interface brief. And you see that I have those 8 interfaces. This is an 8-port switch now. The PEP-C is an 8-port virtual switch. Each port is 10 gig each. You do show module, you'll realize that. Module number 3 is 32 total ports, 10 gig each. Out of that, I got 8 ports assigned. I can give it to the customer and I can tell the customer to tell it to this particular switch from the outside world, and he will never come to know that this switch is actually part of a larger switch. He will think like he is part of he has his own switch because it's a virtualized switch. It's a VS, it's a VDC. Guys, any doubt, any confusion that we have on this?
I mean, is it always that the port groups are 8 ports, or we can have?
So it could be 4, it could be 2. So as I said, today we don't have that problem. It used to be there earlier in the older times. Today, most of the modules have their own single port ASIC. They don't have port groups. Initially, there was a capacity issue, but yes, a couple of more modules, they have like 2-port module. I've seen 4-port module also, where one single port group has 4 interfaces. You have 2 interfaces also in a single port group. Yes, that's there. Okay, so I'm going to do one thing. I'll just go to these interfaces. I'll say switch port and I'll say no shut. Okay, other thing I want to show you here is, you see that these are routed ports, not switch ports. Why is that? Because it's an M module. That's the reason they're by default, they're in the layer 3 state, right? They are routed ports. What did I do? I made them switch port, layer 2 ports. So I'll go back here. I'll say show interface IP interface brief. Sorry, show interface brief, and I can see here, these 2 are now access ports, L2 ports. I'll go back to these ports again. Switch port mode trunk, right? That's all I need to say. And then I go back here, show interface brief. They are trunk ports now. Rest of the ports, you see that they are, you see link node connected means my side, at least we have the SFP. At least they have the SFP, which means there is some kind of cable or SFP connected. What is the meaning of these? That means even SFP is not there. So there is no chance this port is going to be ever up because it doesn't have any SFP inserted, which means no cables inserted inside it. Right? These ports show me that yes, SFP is there. Link not connected means the other side may be shut down. But yes, there is an SFP out there, right? So Nexus gives you that capability to detect that SFPs are there or not, the physical state of it. Now what I'll do is I'll exit out of it and I'll go back to the other switch, which is basically VDC core. And I'll say allocate interface E. Now guys, somebody's background noise is coming. Can you mute yourself, please? Yeah. Then I can have E3, and I'm going to pick next ports, which is 9 to 16 here. Allocate interface, oh sorry, E8 is this one, right? So I'm actually going to the coke and I'm assigning 8 more ports to the next switch. Okay, done. And I'll go back to switch to.
Because I cannot see the screen you're typing. You probably need to scroll down, or it's hung for me, I believe.
Is it, guys, can you see that, the screen?
Yeah, we can see it.
Yeah, it is clear.
Right, is it? So there may be an internet issue, you know, especially if you're on the wireless kind of thing.
I believe, yeah.
No problem. So I have it all beautifully recorded. My side is very clean recording. So I'll actually send you the recording link. So we'll say switch to VDC, and then we'll go to the Coke, the second VDC, right? It's asking me to set up the password for the first time because it's a new virtual switch. You see that how simple it is to create a VDC, just 2 commands, VDC name, allocate interface, that's all. You cannot have a more simpler feature in Cisco than this, right? Just a VDC name, allocate interface, and that's all. Then you go to using the command switch to VDC, you enter into the VDC virtual switch, and here you do show interface brief to see you have the ports connected. See that SFP note inserted, but there are a couple of ports available to me, but they're routed. So what I'll do is, I'll go to these guys, 9 to 12, I'll say switch port mode trunk, no shut. Show VDC. Sorry, show spanning tree. Let's see. You see that spanning tree is there, port number 9 is connected somewhere, right? Show interface brief again to see my ports are up or not. Yeah, the ports are up. Okay, if I do show CDP, sorry, show CDP neighbor, I can see that actually, you know, this particular switch Pepsi is connected to Coke. Let me go back to the diagram. What did I do? I connected port number 1 and 2 here, connected to port number 9 and 10 here. Because I just turned on these things and the cabling is basically is already done here. Now you will be very surprised what is happening, you know, because let's look at this module. Let's bring it here. Okay, I'm going to bring this here. So what has happened in the cabling is the cable number 1 goes to port number 9 and cable number 2 goes to port number 10 on the same module. Right? And 1 to 8 is assigned to, let me pick up this color, is assigned to this guy, 1 to 8, right? And 9 to 16 is assigned to whom? 9 to 16 is assigned to whom? These guys, right? So 9 and 10 is because they're part of 9 to 16. And if there is a cable that exists between these ports, right? So although I am on the same switch, same module, I'm acting as these two are 2 different virtual switches. And I have given to 2 different customers. And they have a trunking between them, which is their choice. If they want to have choice, you know, the trunking is fine. Otherwise, I can physically remove these cables. They don't have anything. Maybe he has his ISP connectivity. He wants ISP connectivity. I'll give him. Guys, any confusion, any doubt on this? Okay, what if I want to do any kind of spanning tree between these 2 people? I'll just create a VLAN 10 to maybe 15, right? Show VLAN. I see these couple of VLANs are active now, right? I do show spanning tree VLAN 10. Okay, show spanning tree VLAN 10, and you can see that here. These are in blocking state. Why these ports are in the blocking stage, guys? They're in forwarding now, right? How can you have two ports to the same switch in the forwarding state? Guys, anybody will explain me that? How can you have two ports to the other switch going, right, to the same kind of switch? I have two of my ports going to the other switch, but they are basically, both are in forwarding. One should be blocking, right? That's a spanning tree rule.
Maybe on the other switch there is blocking. Maybe this is the root switch.
Yeah, so but you can't have two ports in the forwarding state, right?
Does VPC concept come in picture?
Not really. See, the other side, we did not even create VLANs, so that's the reason. If the same VLAN exists there, then because these are per VLAN base, right? Because the VLAN doesn't exist, there's no question of blocking. But if there is a VLAN out there, then the blocking will come into the picture. So I go back to this again, switch to VDC PEPC. And here also I'll create VLAN 10 to 15. And you say show spanning tree. VLAN 10, and you see that one is in blocking. Right, these are basic fundamentals of your layer 2 spanning tree and all that. So if you have two ports, but there are no VLAN 10 to 15 on one side, it won't block it because it doesn't have, you know, it's a per VLAN communication. These are like PVST. If you don't have that VLAN, there's no point in blocking. Okay, so now the VLAN is there, I can block. I have one port in forwarding, the other is in blocking. You see that I am the root. Why is that PEPC is the root? Why is it this guy is the root and the Coke is not the root? I'll go back to Coke and I'll do show spanning tree VLAN 10, and you see that he is not the root. But if you look at that, this guy, all VLANs are basically, he is the root. Why is that, guys?
Lowest MAC address, lowest.
Absolutely, absolutely. So let me show you the logic here. When we were creating VDC, they were assigned a base MAC reference, MAC address. So PEPC had C2 and this guy is C3. That's the reason PEPC wins, because PEPC is C2 and this Coke is C3. So that's a bigger MAC address. Who wins? Lower MAC address. When the priority is same, who wins? The lowest MAC address, right? So that's the reason PEPC will always be, no matter how many VLANs you create, is always going to be by default the root. Right, guys?
Yes. Is there any possibility that I can tweak and make Coke as the root?
Yeah, so you can do the basic spanning tree. You increase the priority on the other side because priority take precedence over MAC address.
Yeah, okay.
So
that's possible.
Yeah, so basic rules of spanning tree are not changing.
Okay.
Right? What VDC impacts is only this MAC address, the way MAC addresses are created. That's the only thing impacted, rest nothing else. The whole spanning tree is intact. You have all your spanning tree functionalities intact. You can do priorities, port priorities, root priorities, primary routes and root secondary, root primary. You can do root guard, loop guard, UDLD guards. All your features are absolutely intact. Okay, so spanning tree doesn't change. The spanning tree behavior changes because VDC does few things very specially and very differently. Okay, so this is it for today, guys. I don't want to actually get into too much of stuff now. Okay, I want you guys to study a lot on the VDC so that you have a fair idea about things, because tomorrow we will do the advanced VDCs. Okay, where I'll tell you the boot orders and a lot of other advanced features, how to tweak things, and then advanced spanning tree to be done on these. Guys, any other question? Okay, or any other?
Because just one quick question. So regarding the throughput, you mentioned it, right? I mean, it's mainly purely based on this XBAR, or it's based on the supervisor actually. I'm always confused with that one.
Yeah, so basically the throughput is actually completely dependent on the crossbar. Okay, so if you read the crossbar documents, you will actually realize the complete throughput. So let's say Nexus throughput. Okay, so let's go here. So these are, this is what it is. So 110, you have 5 modules available. So you have 550 Gbps of throughput basically.
Okay.
Okay, so when you read that document, you will actually realize that this is why they are saying 550 Gbps throughput. Let me write 550 Gbps throughput Nexus. Okay, so that here it is. Okay, so here it is. So it's per slot, right?
You mean the per fabric plane actually?
That's right. So it's a backplane capacity.
Backplane capacity. Okay.
So that's the backplane capacity, which means the kind of throughput for the whole. Even if your interfaces can go more, doesn't make any difference, because you have to cross the one module and you have to go through the other module to actually reach somewhere.
Got it. But somehow in the design, suppose if I'm designing some fabric plane or some data center, so whatever the interfaces I'm provisioning, right? So suppose if all the cards were M2 cards, M1 and M3 cards, it should matches with the throughput of the device actually. So it should not exceed more than that, right?
Absolutely right. Absolutely right. So to increase the throughput, what you can really do is throughput is between the modules. Remember that. But if you want to increase the throughput, you don't actually let the traffic enter through one module and exit through other module. Because in that case, you are going to use XBAR.
Okay.
But if you have your entry and exit from the same module, you will actually end up having much better capacity. It's like these.
Okay. Got it. Yeah, one more silly question. I mean, the XBAR and the fabric plane both are same, right? I mean, just
absolutely both are exactly same. Yes, fabric plane and the XBAR are exactly same.
Okay. Cool. Yeah, that makes sense. Thanks, you guys.
All right, excellent, guys.
So by that we mean that the communication starts and ends on the same slot. It never even goes to the fabric path.
That's correct. Yes.
Oh.
So it doesn't really require any external, out. It basically comes out from the same switch. Same
internal switching or internal routing happens.
That's correct. Right. Internal switching or internal routing. That's correct. Okay, guys. Any other question that we have on today's class? Any feedback you want to give? Anything that I can improve on?
Vikas, can you hear me?
Yes, I can. Yes.
I'm sorry, because I probably last 20 minutes I couldn't hear anything because of, I don't know, there's some messed up network here, I guess.
Sure.
So please send the video recording.
Yeah, in the next 5 minutes, I'll send you everybody the same email. I'll send you a link which will have both the yesterday's and today's recording. as well as all the workbooks
Yeah.
and study material. Yes.
I can still hear you because the voice is breaking. I'm sorry because the network is extended. And thanks a lot. Thank you.
All right. Excellent, guys. I'll see you tomorrow. Take care.
Yeah, thanks, Vikas. Bye-bye.
Thanks. Bye-bye.
Bye, sir.